this computer. Hey everyone, welcome to CSI Secret Store community call. Today is the August 5th, 2021. This call falls under the CNCF Code of Conduct and is being recorded and will also be published to YouTube. So today we have no items on the agenda. So what we're doing is just going through some of the issues and discussing on those. And then we'll probably also have a demo on the Helm upgrade hook. So we released 01.0. One issue that we got, which was created on the provider side, was the upgrade jobs don't truncate the name. So if the user is using an extremely long name today for the Helm release, then the release fails with the name cannot be longer than 63 characters. This is a more obvious issue if the secret driver charts are used as dependencies in provider charts. And I think like one way to avoid hitting that issue is by actually setting a full name override for the dependent charts in the provider charts. So that is something that we'll be including in the next release. But that was the only one issue that we got. And then the second one was if you install, which Nilek talked about before the recording, that is if you install the v0.1.0 Helm release, and then if you want to roll back to a previous version, which is 0.0.23, because the CRDs have been moved to CRDs directly, Helm will not allow you to do that. And then the error would be that the CRDs don't have the annotation saying it's managed by Helm, so the rollback is not possible. And right now it's not there in our release notes, and we'll be adding it to our release notes. So this was one issue that I wanted to discuss. So what we've been seeing is when we actually cut a release, the image build on Google Cloud Builder takes about 1 hour, 15 minutes. So we build 6 images, 2 Linux, that is AMD 64 and ARM 64. And then for Windows, we build 1809, 1903, 1909, and 2004. This build specifically on GCB takes about 1 hour, 15 minutes, and most of the time is spent on downloading dependencies and then building the binary. So there were a couple of options that we can try to speed it up. Like one is build the binary outside. So build once for Linux, AMD 64, ARM 64, and then once for Windows, AMD 64. That was the initial approach that I had documented in this issue. But one problem with that is these builds will no longer be reproducible because the binary is built on the host and then it's being loaded into the Docker container. So the other approach that most of the Kubernetes projects does and like other CNCF project does is basically vendor the dependencies. So they have a vendor directory that they maintain. And for go build, it's just go build -mod equal to vendor. So I wanted to bring that up for discussion here and see what the other contributors think about going with this approach. So if we do this, it'll speed up the build process considerably.
I think that makes sense. Is there any, I guess, what do other projects do to make sure that it's always up to date since it's built outside?
Yeah, so every time they update a dependency, so every time a go mod file is updated, they also update the vendor directory. So like each change is updating the vendor and the go mod at the same time in the PR.
Okay, gotcha.
Yeah, so if folks think this is something that we can do, then we can include this in the next release.
Yeah, I think that makes sense, and it's going to help the whole time it takes to build it to release, right? So
right,
that will be great.
Yeah, I agree too.
Thank you. And I think like one pressing issue that we've seen lately is basically the Windows tests have been really flaky. And the reason for that is this bug in node driver registrar. So node driver registrar is the component that registers the CSI driver with kubelet during startup. And with Windows, what we've been seeing is when the node driver registrar comes up, kubelet does not make the RPC call to invoke the driver registration. So basically, this is the call that the registrar has to get from kubelet. And what we're seeing on Windows is this call does not come. And this has been happening a lot with 121. So 2 or 3 weeks back, we upgraded our Kubernetes versions to 121 for all the Linux and the Windows test. And then we saw Windows failure like quite often. So we rolled back to 120, and then we have been discussing on this issue. I think the issues are somewhere in the kubelet code, but I think the node driver registrar have implemented a temporary fix, which is basically adding a new mode in driver registrar, which can enable liveness check. So we can configure a liveness probe on node driver registrar to check if the driver is registered. If the liveness probe fails, it'll restart the node driver registrar, and it'll do that until the driver is registered successfully. So this PR to add that mode has been merged, and then the release is planned for the next 2 weeks. So once that is done, we can update to the latest image, and then we can also start testing on 121 Kubernetes version for Windows.
Okay, gotcha. And this is a good, I mean, this is not just for this project, but all the drivers, right?
Yes.
Basically, okay. Is there a test for the no registry? Like, why did we not see this before the release?
So I think this is so like I said, right, this issue is not really node driver registrar issue, because this callback needs to come from kubelet. So this has to be in the kubelet code for Windows. So we have also reached out to SIG Windows on Slack.
Yeah, maybe we can add a test for this if it doesn't exist already, for SIG Windows.
Yeah.
Maybe that's a good follow up for them. I don't know.
Yeah, sounds good. I think the last directive that we received was, when this issue happens, check the Unix socket if the module is running. And I did check on one of the local clusters and it was running. So there's a conversation on Slack about that. But this issue seems to be more prominent on 121. Like on 121, when we upgraded, we were just seeing failures every time. Like there was only 1 or 2 passes. So
I see. Yeah, thanks for following up. And this is a good change for, upstream. So
yeah,
not just this project.
And then
Morning, everyone.
Hey, Dan.
Good morning.
Hello.
Yeah, and I think that is the main issues. But we have the stable milestone planned for September 13th. So that's what we're working towards, basically enhancing the tests that we have, making sure it's not flaky, and then also making sure all the docs are there, and then also just the production readiness. The stable release will be with what we have today that has been well tested and used. So that is basically features like rotation, sync secrets, which is there today. And we'll have a 1.0 release with that. So before the 1.0, I'm thinking we will have another mid-release because the last release was the first one where we actually did release branches and all the other release processes. So like we had to make changes in the pipelines and everything to get it working. So now that we've got that done, we're going to try another release, which will include like few bug fixes, like on the Helm chart side, and try out a release branch to just get the process hardened. And then we also have a PR to document the process. So like when we do the next release, we'll basically merge the document PR as well so that others can cut the release. And after that, the next will be the stable release that we are planning for, unless anyone has any other blocker that they think we should include in the stable release.
One question about the stable release, like, do we differentiate like which features are alpha, beta versus when we say stable, is it just a driver or all the features are stable as well, all the feature flags?
So it's only the driver default features. So that is the
Mhm.
mount and the sync.
Gotcha.
Rotation remains in alpha. That's because we eventually want to move to requires republish. So that is where we want to head to.
Gotcha. Something to kind of think about is if we were to move the sync to another project,
Mhm.
you know, what would deprecation look like here once it's stable, right? Something to think about.
Right. Yeah.
I would love to hear users' feedback actually.
Yeah. Yeah. We haven't actually published an issue saying that is where we're headed, but I think so me and Tommy are working on the design doc. Once we have that, we'll create an issue and then tag the design doc, so we can start a conversation there to see if users have any feedback on it as well.
Okay, great. And definitely open an issue so people can chime in.
Yeah, sure. Okay, and this is all for the issues. I think Dane posted that you have a question.
I do. So I was working on the sync all feature for the custom resource. And I enhanced it a bit to be considerate of the different types of secrets. But I had a blocker. I noticed that when I got all the secrets to sync, and the user could specify the type, but when I deleted the pods with those mounted secrets, the secrets weren't deleting. So I wanted to ask how the driver knows to delete the secret when the pod has been deleted. I don't think I understand how that works.
So you're referring to the Kubernetes secret?
That's correct.
Yeah, so for the synced Kubernetes secret, what the driver does is when it creates it, it also adds the pod as owner reference. So you create a pod initially, and then basically that's referencing a secret provider class, and then it's also requesting for syncing as Kubernetes secret, right? At that
Right.
point, the driver creates a Kubernetes secret, and then in owner references, the driver adds the pod as the owner for that Kubernetes secret. So when you delete the pod, the owner is deleted. So Kubernetes will automatically garbage collect it rather than the driver doing it periodically.
Okay. So it needs to have that owner reference in order to be able to delete it, or to know to delete it.
Right.
Okay. That's probably enough info for me to dive in and try to figure out why it's not deleting, but I might message you to confirm if I'm understanding that correctly, if I can't find it.
Yeah, sure.
Awesome. Thank you.
Glad to see more progress on that feature, Ding.
I've been struggling to find time for it because I just got a job recently. So then that's where all my time's been. But
It's okay, baby steps.
Yeah, very, very small steps. But I would like to hopefully have it done by like the next meeting.
Yeah, feel free to reach out if you have any questions.
Oh, that was another thing. I've been doing all of the testing in Vault. I might need help on seeing if it works with like Azure as well as GCP, because I don't have accounts for either of those, and I'm not sure I'll be able to find time to figure it out. So I might reach out for some help on testing it with those providers.
Sure.
Thank you.
Okay. Without putting Nilek on the spot, Nilek, do you want to do a demo now? Or
Yeah, sure. Yeah, I can do it.
let me give you share permissions. Okay, you should be able to share now.
Uh-oh. Give me 1 second. I need to give the permission. I might have to quit and join back.
Go for it.
Hello, can you hear me?
Yes.
Okay, let me try sharing the screen now. Screen. Okay, can you see the screen?
Yes.
Okay, so I have the kind cluster here. Okay, so what we are demoing is basically so recently we implemented CRD upgrade hooks. So with which we will be managing how we are installing the CRDs and how we are upgrading the CRDs. Since with Helm 3, Helm is not going to manage the CRDs for the user. So we implemented the custom Helm hooks, which will allow us to do that. And before showing you what we implemented, I will first show how it works, and then we'll take a look as to how we implemented it. And then what we'll try to do afterwards is we will try to modify our CRD and see if Helm upgrade works as well. So okay, so we have a make target which will install the deploy release. So I have a client cluster created over here. So we'll just install our regular so let me okay, so I think I was testing before, so that's why it was saying it was already there. But if you can see over here, we created basically 3 resources. We created a service account, we created a role and a role binding for that service account, and then we actually create a CRD hook in order to create the or install the CRDs. So if you see over here, we first delete any existing resources that it has. So we'll if there are any of these resources present in the cluster, it will delete itself, and then it will create it again. So we have service account created, we have cluster role created, and then cluster role binding created, and then it will install the it will install this job which will run a pod, and inside the pod we are just doing the kubectl apply. So that way it will install the CRDs, and then if we come down here, we will see all of our hook resources. What are the resources that we are created? And probably it's better if I show it in here. So basically this is the upgrade hook we have, and as I was mentioning, we are creating a different resources in order to give the right permission for this. So we have a cluster role and then cluster role binding, and we have service account which we hooked or which we give permission to permission so that the pod which is actually doing the CRD install will have all the necessary permission to it. And then we have a job. So initially we had a pod. Initially, the way we had implemented it, we just had a pod, and pod used to do like the same. I mean, it was using the same image, and it was just doing the cookie cutter apply. But then the issue there, what we found was it was not waiting for the it was not waiting for this command to be fully completed, and it was exiting before that. And what Anish found is like we can use a job instead, and then that way the job will actually wait for pod to pod to finish, or pod to go towards the complete state, and then that way we know for sure that CRDs are installed, and then we'll move ahead with the remaining Helm install. So that was the update we did to this installation. So yeah, so this is what pretty much goes with the resource. One thing that I personally learned was the Helm annotation, and specifically the Helm delete policies. Like this is I was worried about. So like we are giving a lot of these permissions to this service account, and how can we get rid of it? But with this, if we specify this annotation, Helm takes care of deleting all the resources. So if we switch back here, we can see that all these things, whatever we are creating, are being deleted immediately as well. And then we proceed with the remaining Helm install. So, and let's see. So we basically, if we see, then we have this CRD installed. And if I get, oh, sorry, if I do this, oh, let me try to delete this.
While you do that, I do have a question about the job versus pod thing.
Sure. Sure.
I noticed a lot of other projects, they all use pod. Is there something special here that?
What do you mean? I mean, we switch from not using pod to job.
Right. I guess I was just wondering, other projects have been using pod for that hook, for the upgrade hook. So I'm wondering if other projects have maybe seen the same issue where the you know, the kubectl apply hasn't finished before all the other components run in the Helm upgrade process.
So this could be also just a Helm related issue, because I was trying this out a few days before release, and then I observed that Helm is only waiting for the pod to reach completed state, right? And like every time I was looking at the logs, the pod starts up, and even before it starts running, it just goes into completed and starts terminating. And then we tried to repro this with an older version. So Nilek had an older version of Helm, but we actually didn't see the issue there.
Oh, interesting.
Yeah.
Okay.
And interestingly, job's behavior was consistent across all versions of Helm, because the job gets created and it needs the job to go to that state. So like it waits for the job to actually go to completion.
Right. And I guess in this case, it doesn't matter, right? Because it's the process that just runs at the beginning anyway.
Right.
Meaning it doesn't need to stay around. So
that's right.
Okay, I'm gonna ask other project if they're seeing something similar with the pod, because almost everybody uses pod just because it's the first thing that people think about, right?
Right.
Curious, this is like, which Helm did you try that had this issue? What version?
let me share the PR. I think I added the notes there.
Okay, thank you.
Okay, let's see. Something is not right with my demo. Okay, I need to take a look at this.
Now, so what are you trying to do? Are you trying to see?
So what I was trying to do was just see the YAML and
just do kubectl get CRD, the secret provider class. You're doing get, so it's actually showing you instances of the secret provider class. Get CRD and then the CRD name dash YAML.
Oh, just this one. Oh.
Because the other one is just showing you the instances of secret provider class.
Oh, okay. I'm not sure. I'm running off of my custom branch as well, which I'm doing modification for the doc provider. So I'm not sure if that is creating any problem. But that's the, I mean, I pretty much wanted to show the installation part. The only thing I was gonna try to show is like maybe if we can add another parameter over here and do Helm upgrade, so it also reflects the actual. I mean, it will also reflect into that YAML in CRDs. Sorry.
Try the command that Anish put into the chat.
Okay.
Or I think you'll have to change KG to K. But let's have that to go.
Oh, there you go. What did I type then? Anyways, figure out.
I think you typed secret provider classes, but you're supposed to type the full name of the secret provider class.
Tried that as well. Anyways, I can figure it out later. So we have this. Let me see. Let's try to upgrade this or add additional parameter. Like this. And let's do Helm upgrade. With the Helm upgrade command as well, sorry. Oh, smart version. Which I think it is 010. Oh, okay. Stop teaching that. Oh, cannot find the- there you go. Oh, I should have done the debug to get the more logs, but let's see if we can get the upgraded YAML. Oh, I don't see it. Nope. I'm sorry. I need to figure this out. What's wrong? But we should have seen the parameter over here. I'm not sure if the upgrade happened correctly or not.
The change you made in the
Mhm.
YAML, how does that get applied, right? Like the hook,
Oh,
how does
oh,
it get
oh,
it?
oh, oh, oh. Sorry. Actually, you're right. We are using the release chart, so we didn't do any changes over there, and I'm just doing the changes directly in here. So if I apply directly from this directory, then it will take effect. Sorry, my bad. I am installing directly from this guy here. Easy there,
Yeah,
and
that makes sense.
that's why it is not. That's why it is not reflecting. Sorry, maybe I can prepare it really well for the next time and then demo it again.
Yeah, no worries. I think I get the concept though.
Yep.
Cool.
That's it from me
Thank
for
you.
now.
Thank you for the demo on short notice.
Yeah, sorry
Sure.
to put you on the spot.
No, hopefully
Nothing
I'll
like
do
a live
better.
demo though.
That's why I try to script the entire demos. Hopefully we'll do better later in the afternoon. That's it.
Rita, I shared the PR on the chat.
Yeah, I'll
But-
take a look. And I'll test it on a couple of other repos just to make sure this is like if it's a common issue, then we should definitely open up an issue on Helm though.
Yeah.
If it's like a breaking change in new Helm, then we should at least let the Helm team know.
Right.
I'll let you know how it goes.
Cool. Thank you. Okay. I think that's it. Is there anything else that anyone wants to discuss?
Nope.
I'm
Thank
good.
you. It was good to see everybody.
Yeah,
Thank
you
you.
too.
See ya.
Have a good day. Bye.
Bye.
Bye bye.